Hi, everybody. This week we are doing a review of descriptive and inferential statistics. So, in order to take this class, you should have already taken statistics. It is one of the prereqs that are required. So, this will just be a little bit of a review, hopefully, but kind of highlighting a few of those key topics. The reading this week will hopefully be really helpful. I also included a really great video I found on YouTube in the lecture for this week that I thought was an incredibly helpful short review of all of this information in case you need a little bit of a refresher. So we'll look at the differences between descriptive and inferential statistics, some things related to the distribution of a variable, like measures of central tendency and measures of variability. How can we describe statistical relationships, null hypothesis testing and rejecting or retaining the null hypothesis, and then some different types of basic null hypothesis tests like t-tests and ANOVA and so on. So again, kind of a quick review, but hopefully helpful nonetheless. So let's jump in. So descriptive versus inferential statistics, kind of one key difference to highlight here. Descriptive statistics, oh, look at my cat had a lot to say about descriptive statistics. My little nugget cat. Descriptive statistics summarize and describe the features of specific data sets, right? We use things like the mean, the median, the mode, standard deviation, and various graphs. So we're summarizing and describing versus inferential statistics use a sample of data to make predictions, to test hypotheses, and to draw conclusions about a larger population. So one really way like to remember the difference between these two. Descriptive statistics describe, right? The name is describing in itself. They tell you what happened versus inferential statistics predict. They explain why and predict future events. So kind of a key difference between the two, and we'll focus on a little bit of both, but something to remember. Descriptive versus inferential. Description versus prediction. When we talk about the distribution of a variable, the way that scores are spread out across levels of that variable, there are quite a few ways that we can display information, right? And let's look at a few of them, right? So we can do all the ones listed here, and then some frequency tables, histograms, bar graphs, line graphs, scatter plots, correlation matrices or matrices. So there's quite a few, right? And all of these are different ways that we can display how scores are spread out, right, across whatever levels of the variable that we're looking at. So a frequency table organizes data by listing values or categories and showing how often each occur. So this one right here is a frequency table, right? Like we're looking at these grades. We can figure out how many times they happen, what was their frequency, right? So that's kind of one easy way to remember this. It's looking at how often something happened. So we divide it into different levels of grades. We have this little tally, and then right here you can see what the frequency was. A histogram is a graphical representation of the distribution of numerical data using vertical bars. And typically with a histogram, the bars are connected to each other, right? So see how in the bar graph there's space? Histogram, they are all sandwiched together. So this one down here is a histogram, right? On this side, we have one variable, and on this side, we have the other. And then we plot them using like these graphical representations of vertical bars. Right, so that's a histogram. A bar graph, really similar, right? But this one we're comparing distinct categories using discrete data, and the bars are spaced out. Right, so again, we have something here on this axis, we have something on this axis, and then we represent each piece of discrete data or category of discrete data using these spaced out bars. So just a little bit of a distinction between the two, similar but a little bit different. A line graph displays information as a series of data points or markers connected by straight line segments. So this one right here is our line graph, right? So you can see all of these represent a point of data, and then they're connected to each other by segments of lines, right? A line graph is made up of these lined data points, like markers connected by straight line segments. A scatter plot is going to use dots of data to display the relationship, pattern, or even correlation between two numerical values. This one right here is a scatter plot, right? So we have something that we're measuring on one axis, something on the other. We have a ton of little dots, and we can use this to infer things like correlation, right? That you can see from looking at this, there's a negative correlation between these two variables. And finally, a correlation matrix is this one right here, last big one up here. It's a square table that displays the Pearson correlation coefficient, or Pearson's R, between multiple variables, summarizing the strength and direction of their relationship. It's a matrix, or like an outline of a bunch of different things and the correlations between them. So lots of different ways to display the distribution. And again, here we're in descriptive statistics. We're just describing or displaying what it is that we have learned. We also have some measures of central tendency, mean, median, and mode, right? You've probably been hearing about these for a very long time. They're taught to us very early. The mean is the arithmetic average. It's the average score, right? All of the numbers that are in the data divided by the amount of numbers, right? So right here we have all these numbers added up equals 30 there, and then we divide it, and the mean is 6, or I'm sorry, 5, right? Divided by that is 5, right? So we have all of these different numbers divided by 6, which is the number of numbers we have, equals 5. So it's a central tendency measure that is found by summing all the values in a data set and then dividing by the total number of values. It represents like a typical or central point in the data, though it can be very easily skewed by outliers. The median, which is the second box right here, is a measure of central tendency that represents the exact middle value in an ordered data set, separating the higher half from the lower half. So if we have this raw data, we have to arrange it numerically, right, in ascending order. And then we look right for the middle point right here, right? And the median here is 4.5, right? So the exact middle of the data would be 4.5. Notice it's different from the mean, right? We get different levels here, different measures. A mode is a measure of central tendency that is the value that appears the most frequently in the data set. So it represents the most common or popular item or score. So if you look at all the numbers here, the most commonly occurring one was 3, right? 3 occurred twice, right? And nothing else did. So the mode would be 3. And these, again, are a really great way to describe data, right? They are all measures of central tendency, or what is kind of like the common number, the mean, the center point of the data set. We also have measures of variability. And these are things like range and standard deviation. So variability is kind of like the divergence of the data from its mean, right? So a central tendency, center means like central means center, right? Right in the middle. So these are how does the data spread out from that or diverge from it from its mean value. And two of the really common ones we use are range and standard deviation. Range is a measure of the dispersion of the data. It represents the total spread of a data set, calculated as the difference between the highest and the lowest value. And so we see right here, right, if you have this set of data, the highest value was 9, the lowest value was 3. So 9 minus 3, our range equals 6. Or you could do it in the form of a graph, right? The highest score was 100, the lowest was 20, so the range equals 80. Gives us an idea of like where the low and the high was in a distribution. In terms of standard deviation, this is a statistical measure of the amount of variation or dispersion, variability in a set of data values relative to their mean. And so a low standard deviation means that data points are really close to the mean, and a high one would indicate like a higher spread, right? And when we have our beautiful bell curve here, right, typically the mean is right here in the middle. And then we can see 1 standard deviation, 2 standard deviations, 3 standard deviations out, right? And so anything really close is going to be more common. The farther we get away from the mean, the more variability we have, the less commonly occurring that score might be, for example. So it's a really great measure of how dispersed the data is in relationship to the mean. And again, we're still in descriptive statistics. We're just describing the data that we have collected. We aren't doing anything with it except describing it or displaying it in some way. When we're still describing here, we can have linear relationships or non-linear relationships, and they're kind of easy to see, right? When you look at a graph, one is very linear, it follows a relatively straight line, versus one is curved. It's non-linear, right? Very straight line versus a curved line. A linear relationship is a connection between two variables where their change is proportional, as one moves, the other moves in proportion, resulting in a straight line when they're plotted on the graph. Nonlinear means the two variables don't move in that fashion. A change in one does not produce a proportional, consistent change in the other. So it results in more of a curved pattern rather than more of a straight line on a scatter plot. And again, visually, I think you can see these pretty easily, that linear follows this very predictable line pattern versus nonlinear follows more of a curved pattern. So if we shift a little bit to null hypothesis testing and inferential statistics, I love this, right? A little statistics humor. You can never resist statistics humor as a psychologist, right? Can my boyfriend come along? I'm not your boyfriend. You totally are. I'm casually dating a number of people, but you spend twice as much time with me as anyone else. I'm a clear outlier. Your math is irrefutable. Face it. I'm your statistically significant other, right? So statistical significance is something we're going to look at here. This totally feels like something I would do with my partner, right? Like, face it, like statistically significantly, you're with me. But I love this, a little humor before we jump in to hypothesis testing. And when we're looking at this, this is now inferential statistics. We've moved over to the other side. This is an act in statistics where an analyst is testing an assumption about some kind of parameter. So null hypothesis testing provides a structured, objective framework for making data-driven decisions about a population based on sample data. It's going to test an assumption, the null hypothesis, to determine if the observed differences that we see are statistically significant or maybe they're just due to sampling error or chance. It helps validate ideas, manage risk of errors, and infer population parameters. So our whole goal with hypothesis testing is to reject the null hypothesis. Null translates to mean like nothing, like zip, nothing, nada, right? And so the null hypothesis is stating that there is no significant difference between the specified populations, that any observed difference is due to sampling error or experimental error. So when we make a null hypothesis, or like HO as it's sometimes represented, we are saying that there is no difference present, right? That it is only due to like error or chance. And our goal with null hypothesis testing is to reject that. I had a statistics professor in community college, and he was kind of a wonky guy. But he used to say, your goal in research is to say no to the hoe, right? And I don't know why it stuck with me for so many years, right? The HO or the hoe, as he called it, you want to reject the hoe, right? In life and in statistics, according to him. And as silly as it sounded, it stuck with me all these years. That's your goal in inferential statistics, to reject the null hypothesis. No to the hoe. Rejecting or retaining the null is based off of a couple of things, right? So we have what's called a p-value. Your p-value measures the probability of obtaining research results at least as extreme as the ones observed, assuming that the null hypothesis is true. So it indicates the strength of the evidence against the null hypothesis. A lower p-value suggests that the observed data is unlikely to have occurred by chance, thus supporting the alternative hypothesis, right? Which we don't want, right? We want to be able to reject the null if we're able to do so. And you can see this kind of here in the little graph right here, the little chart. We have our bell curve, right? So right in the middle would be our mean, and then we have our standard deviations. The p-value we've defined as this little area over here. And so if we get way over here, it's a very unlikely observation to have made, right? And oftentimes what we do is we set an alpha value. An alpha is the probability threshold that we set to determine the statistical significance. It's usually like 0.05. It's a very commonly set alpha value. And we set this value to allow us to decide if our results are statistically significant or not, which means that the research results, such as the difference between two groups, are unlikely to have occurred by random chance. Or another way of putting it, as it says right here, the claim that a set of observed data are not the result of chance, but can instead be attributed to a specific cause. So we have a p-value and an alpha, and these things are allowing us to either reject or retain the null hypothesis, depending on our findings. There's a lot of different types of null hypothesis tests. I'm not going to go into this a whole lot. You can read a little bit more about it in your readings for this week, but just as a quick review, one very common form of a null hypothesis test is a t-test. It's a statistical tool used in hypothesis testing to determine if there is a significant difference between the means of one or two groups, helping to decide if observed differences are due to chance or a real effect. So with the t-test, we are comparing the mean of group A and group B, finding the probability of the differences to have happened by chance. It's a way of comparing the means of these groups of data. And it can be one sample, it can be one-tailed, two-tailed, it can be a dependent sample, an independent sample. There's a bunch of different kinds of t-tests. One-tailed just means that we're just looking at one side. We're looking at this 5% over here. Versus two-tailed, we're looking at both sides of the distribution. Is there a difference in either direction? It's non-directional versus this one, we're looking at a specific direction. And then again, a couple of different other types of t-tests, which I'll let you read a little bit more about as review in the chapters for this week. Another thing that we can use, much more involved, but another method is ANOVA, or analysis of variance. This one is a statistical method where we can compare the means of three or more independent groups to determine if at least one group mean is significantly different from the others. It analyzes the variance, hence the name, within groups and between groups to assess whether the differences are statistically significant or due to chance. We have one-way ANOVAs, repeated measure ANOVAs, factorial ANOVA. We're using the F statistic or the F ratio as our indicator. Again, a little bit more involved, but this is another way that we can do some hypothesis testing when we have three or more groups that we are trying to analyze. So that is our little review for this week on statistics. I hope it was helpful. As always, if you think of any questions or have any questions for the week, feel free to reach out to me. Don't forget to do your reading, watch that video that I mentioned. That will be really helpful for reviewing, and I will see you all next week.